China is known as the world's factory. It builds cars, phones, ships, batteries, bridges, and almost everything else at a scale that few countries can match. But there is another side of China's manufacturing revolution that is becoming much harder to ignore. China is now building humanoid robots that can walk, run, work in factories, recognize people, copy facial expressions, lift heavy objects, and even interact with humans in surprisingly natural ways. Some are designed to replace repetitive factory work. Others are being developed to assist people in hospitals, homes, and everyday life. And some are being built simply to explore a question that sounds like science fiction. How close can a machine actually get to behaving like a human? Today we're counting down 8 of the most impressive humanoid robots coming from China. Some of these machines are focused on speed and strength. Others are focused on intelligence and human interaction. And by the time we reach number 1, you'll understand why China's humanoid robotics industry is attracting so much attention around the world. Let's begin with number 8. Number 8 is DroidUp Moya. Moya is interesting because she is not designed simply to look like a robot. She is designed to feel surprisingly human. The humanoid stands around 5 feet 5 inches tall and weighs roughly 70 pounds. But her most unusual feature isn't her height or weight. It's what happens when you touch her. Moya's artificial skin can be maintained at roughly human body temperature, around 90 to 97 degrees Fahrenheit. Tiny heating elements inside the body warm the surface so that touching the robot feels less like touching a cold machine and more like touching a person. Why would engineers do that? Because human beings naturally respond to physical warmth. A warm hand, a handshake, or even a simple touch can create a feeling of familiarity and comfort. So the engineers behind Moya aren't only trying to make a robot that looks human. They are experimenting with something much deeper, making a machine that creates a human-like emotional response. Her movement is designed to resemble a natural human walking pattern, and the robot can also perform small facial expressions, including smiles and winks. That matters because of something robotics researchers call the uncanny valley. When a robot looks completely mechanical, we immediately recognize it as a machine. But when it starts looking almost human, something strange can happen. Small imperfections suddenly become much more noticeable, and the robot can feel unsettling. Moya appears to be deliberately exploring that boundary. The reported launch target is around late 2026, with an expected price in the range of $173,000 per unit. And if the idea of a robot with warm skin sounds strange, number 7 is about to take humanoid robotics in a completely different direction. Number 7 is Honor Lightning. Imagine watching a humanoid robot enter a half marathon. Not a short demonstration. Not a few steps inside a laboratory. A full 13.1-mile race. In April 2026, Honor's Lightning humanoid robot was reported to have completed the Beijing E-Town half marathon autonomously in around 50 minutes and 26 seconds. That means the machine wasn't simply being controlled like a remote-controlled vehicle. It was designed to move through the course on its own. For humanoid robotics, that is a major engineering challenge. Running is much harder than walking. When humans run, our bodies constantly lose and regain balance. Every step creates impact forces, and the brain continuously adjusts the position of the legs, hips, arms, and torso. A robot has to solve the same problem using sensors, motors, control software, and artificial intelligence. Lightning stands around 5 feet 7 inches tall, and its leg design is built to support long, efficient strides. Its joints are also designed to produce enormous amounts of torque, giving the robot the strength needed to accelerate and maintain balance. But perhaps the most interesting part is how quickly the project was developed. Honor reportedly brought together more than 2,600 engineers and developed the robot in less than a year, a remarkably short period for such a complicated machine. That tells us something important about China's robotics industry. Humanoid robots require expertise from many different fields at once. Mechanical engineering, artificial intelligence, computer vision, battery technology, motor control, materials science, and software engineering. The companies capable of bringing all of these technologies together quickly have a major advantage. And Lightning is a perfect example of that approach. But if a robot can run like a human, what happens when engineers focus on something even more human? The human face. That brings us to number 6. Number 6 is the humanoid head known as Xuan. Most humanoid robots have extremely limited facial movement. Their eyes move, their mouth opens, their head turns. And that's usually about it. Xuan takes a very different approach. The robot's head contains around 30 individual facial muscles, with each movement controlled by precision motors. That allows the face to create a much wider range of expressions. a slight change around the eyes, a movement of the mouth, a small adjustment of the cheeks. Together, these tiny movements can make a machine appear much more expressive. Xuan was created by a team led by Dr. Yu Honghu, a Columbia University PhD, with support from major investors including Shunwei Capital and Agibot. And in 2026, Xuan attracted attention after appearing at a Shanghai event where the robot performed a Chinese love song. The performance became widely discussed because the robot could combine facial expressions with speech and singing. But there is an important detail that makes Xuan even more interesting. Xuan cannot walk. And that may actually be intentional. Building a robot that can walk requires enormous amounts of power, computing capacity, cooling, and mechanical complexity. Building a face with extremely detailed expressions requires many of those same resources. So instead of trying to solve every problem at once, engineers can specialize. Xuan focuses almost entirely on communication and expression. That raises an interesting question. What matters more for a social robot? Should it be able to move like us? Or should it be able to communicate with us? Xuan is betting on communication. Number 5 takes the opposite approach. It doesn't care about entertaining you. It goes to work. Number 5 is the UBTECH Walker S2. The Walker S2 is designed for one of the biggest potential markets for humanoid robots: industrial manufacturing. Instead of performing on a stage, these robots are being developed for actual factory environments. The Walker S2 has been associated with automotive manufacturing operations, including work connected with NEO. Its tasks can include inspecting vehicle components, checking alignment, handling parts, performing quality control activities, and moving materials between different work areas. And here's the problem it is trying to solve. A robot can be incredibly strong and intelligent, but if its battery needs to be replaced every few hours, it becomes difficult to use continuously. UBTECH's solution is surprisingly simple. Make the robot change its own battery. The Walker S2 is designed to replace its battery pack in just a few minutes. Think of it like a Formula 1 pit stop. The difference is that the robot doesn't need a human mechanic to do the job. It can return to a charging or battery changing station, replace its power pack, and get back to work. That could become extremely important in factories. Traditional industrial robots are often fixed in one location. Humanoid robots have a different advantage. They can potentially move through environments designed for humans without requiring an entirely new factory layout. They can use stairs, walk through production areas, reach workstations, and potentially perform multiple different tasks. UBTECH has already attracted significant commercial interest for its humanoid systems, with reported orders reaching more than $100 million. The company has also targeted thousands of units for production. And the technology is not limited to automotive factories. Humanoid robots like Walker are also being evaluated for other demanding industrial environments, including aircraft manufacturing. The important point is this. Humanoid robots are slowly moving from demonstrations into real workplaces. And that brings us to number 4, where the boundary between robotics and human education becomes even stranger. Number 4 is DroidUp Juba 01. At the 2025 World Artificial Intelligence Conference in Shanghai, DroidUp presented an unusual experiment. Instead of sending its humanoid robot into a factory, the company placed it into a university environment. Juba 01 was reportedly admitted to the Shanghai Theater Academy to study traditional Chinese opera. Yes, a humanoid robot entering a university program. The robot was intended to study subjects connected with performance, emotional expression, storytelling, and interaction between humans and machines. Obviously, this does not mean the robot learns exactly like a human student. It does not experience emotions or understand the world in exactly the same way we do. But that is precisely what makes the experiment interesting. A university environment gives researchers a completely different testing ground. Instead of asking whether a robot can lift a box or walk across a factory floor, they can ask whether a machine can observe human behavior, interpret expressions, reproduce movements, and interact socially. The name Juba itself is associated with the idea of a top-performing student. But behind the branding is a serious question. Can humanoid robots eventually become part of ordinary human environments without constantly needing special treatment? Imagine a robot that has to navigate classrooms, hallways, conversations, instructions, unexpected situations, and social rules. That is much more complicated than simply walking from point A to point B. Juba 01 is therefore less about replacing a human student and more about testing what happens when humanoid robots enter environments designed around human behavior. And now we move to number 3. This one may be the most disruptive robot on the list because of its price. Number 3 is the EngineAI PM01. At around $12,000, the PM01 is positioned as an unusually affordable humanoid robot. And when you compare that price with many other advanced humanoids, it becomes clear why the robot has attracted attention. But price isn't its only interesting feature. The PM01 can rotate its waist by around 320 degrees. To understand how extreme that is, think about your own torso. A human body can rotate only so far before the spine and muscles stop the movement. The PM01 has a mechanical structure that allows a much greater range of rotation. That can be useful when the robot needs to reach objects in tight spaces or manipulate something without completely repositioning its feet. The robot stands around 4 feet 6 inches tall and weighs roughly 88 pounds. It also uses multiple processors to handle movement and object manipulation. But perhaps the biggest opportunity isn't the hardware. It's the open development approach. When robot hardware and software are accessible to developers, universities, startups, and researchers can experiment with the machine without having to build an entire humanoid from scratch. That could accelerate innovation. Think about what happened with personal computers and smartphones. The hardware mattered, but the ecosystem of developers created much of the real value. Humanoid robots could eventually follow a similar path. A low-cost platform gives thousands of researchers access to technology that previously required millions of dollars. And that could dramatically accelerate development. But if affordability is the biggest strength of the PM01, number 2 is built around strength, precision, and human assistance. Number 2 is the Fourier GR-1. Fourier Intelligence has a background that makes this robot particularly interesting. Before developing humanoid robots, the company worked extensively on rehabilitation technology and robotic systems designed to assist people. That experience is reflected in the GR-1. The robot has around 40 degrees of freedom. In simple terms, that means it has many independently controlled joints throughout its body. Its movements can therefore be much more complex than those of a simple machine with only a few motors. The GR-1 stands around 5 feet 5 inches tall and weighs approximately 121 pounds. It can walk at more than 3 miles per hour and has been designed to carry heavy loads. But strength isn't necessarily the main purpose. The real opportunity is healthcare. A humanoid robot working in a factory may need to move quickly and repeatedly. A robot assisting an elderly person or working in rehabilitation needs something different. It needs to understand physical contact. It needs to know when it is pushing too hard. It needs to recognize resistance. And it needs to adjust its movement accordingly. The GR-1's force-sensing technology is designed around this kind of interaction. That makes it particularly interesting for hospitals, rehabilitation centers, and potentially elder care environments. Imagine a machine that can help someone stand up, carry equipment, move supplies, support rehabilitation exercises, or assist a patient without putting too much pressure on their body. That is a very different vision of humanoid robotics. Instead of replacing humans, the robot becomes a physical assistant. And now we reach number 1. The robot that brings many of these ideas together. Number 1 is Xiaomi CyberOne. Xiaomi has spent years developing its humanoid platform, but the company has been unusually cautious about turning the robot into a commercial product. That makes CyberOne fascinating. Because Xiaomi already has enormous experience manufacturing consumer electronics at scale. The company has factories, software engineers, artificial intelligence expertise, supply chains, and a huge global customer base. If Xiaomi eventually decides that humanoid robots are ready for mass production, it already has many of the ingredients required to attempt it. The newer CyberOne development has focused heavily on making the robot more capable and more practical. Its hands have been redesigned to become more compact. Its cooling system has been improved to manage heat during demanding tasks. And the robot has been designed to recognize human expressions and environmental sounds. According to the claims surrounding the system, CyberOne can identify dozens of different human emotional states and respond to a wide range of sounds. That is important because a useful home robot cannot simply understand commands. Human communication is much more complicated than that. Imagine someone saying, "I'm fine." The words might be simple, but their facial expression, voice, posture, and tone could tell you something completely different. A truly useful social robot would need to process all of those signals together. It would need to recognize what is happening around it and choose an appropriate response. That is where artificial intelligence becomes just as important as mechanical engineering. The ultimate goal is not simply to build a machine that can walk. Walking is only the beginning. The real challenge is creating a machine that can understand an environment, make decisions, manipulate objects, communicate with people, and operate safely around them. And this is what makes China's humanoid robotics race so interesting. Look at the 8 machines we've just explored. Moya is focused on human-like appearance and physical interaction. Lightning demonstrates extraordinary mobility and autonomous running. Xian focuses on facial expression and communication. Walker S2 targets real factory work. Juba 01 explores human education and social interaction. The PM01 is pushing toward affordable humanoid hardware. The GR-1 is targeting physical assistance and healthcare. And CyberOne represents a broader vision of humanoid robots potentially entering everyday life. These robots are not all at the same stage of development. Some are prototypes. Some are experimental platforms. Some are being tested in real workplaces. And some of the more ambitious claims around future capabilities still need to be demonstrated at large scale. But the direction is clear. Humanoid robotics is moving from science fiction demonstrations toward practical engineering. And China is investing heavily in making these machines cheaper, faster, stronger, and easier to manufacture. The biggest question is no longer whether robots can walk. They already can. The bigger question is what happens when thousands and eventually millions of machines can walk into environments designed for humans and perform useful tasks. Factories could change. Warehouses could change. Hospitals could change. Construction sites could change. And eventually homes could change too. But there is another side to this revolution. The closer robots get to human appearance and behavior, the more complicated our relationship with them may become. Would you trust a robot with an elderly family member? Would you allow one to work inside your home? Would you feel comfortable with a machine that can recognize your emotions? And if a humanoid robot becomes good enough at conversation, movement, and facial expression, would people begin treating it like something more than a machine? Those questions are still open. For now, one thing is certain. China's humanoid robot industry is no longer just a collection of laboratory experiments. It is becoming a serious technological race involving artificial intelligence, batteries, motors, sensors, computer vision, advanced manufacturing, and enormous amounts of investment. And the machines being developed today could become the foundation for an entirely new generation of robots. So, which of these 8 humanoid robots impressed you the most? Would you choose the incredibly expressive Moya? The record-setting Lightning? The factory-ready Walker S2? The affordable PM01? The healthcare-focused GR-1? Or Xiaomi's CyberOne? And perhaps the bigger question is this. Would you actually want one of these robots living or working alongside you? Let me know your answer in the comments. If you enjoyed this deep dive into China's latest robotics technology, make sure to like the video and subscribe to Nextgen videos for more documentaries about artificial intelligence, engineering, mega projects, and the technologies shaping the future. Because the robots of tomorrow are no longer just being imagined. They are being built right now.